Welcome back to a new video from the Math Survival Guide offered to you by the Custer Academy. My name is Luc de Custer, founder of the Custer Academy. In this video we'll talk again about polynomials, but we're going to look into the subtraction of polynomials. But before we start with this, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about. Let's have a look at polynomials and subtractions. Now, when we looked at the real numbers and we defined addition and subtraction of real numbers, we could say that when a and b are real numbers and a plus b is also a real number, we define the subtraction as a minus b, which is equal to a plus the inverse or the negative of b. And this subtraction is also a real number. Now we can do the same thing for polynomials. And basically we can also write that when we have two polynomials am minus bn, that we can write this as the sum of am plus the negative of bn. And when we look at the expressions of the polynomials, we can say that we have the summation of a index I times x to the power I going from I equal to 0 to m, plus the minus the negative of the second polynomial bn, which is defined as the summation from b index I times x to the power I going from 0 to n being the order of this second polynomial. So we take the negative, but taking the negative also means that we're in fact taking the negative of the coefficients of the powers of x. And adding those, we will be adding the coefficients of the first polynomial with the negatives of the coefficients of the second polynomial. And that's basically what we're going to do. Now let's have a look at the first example. We have two polynomials a, m, equal to 5x to the power 4 plus 3x plus 2, and bm is 3x to the power 4 minus 4x to the square minus 2. Both polynomials have the same order, the order is 4, and now we can say that minus b is minus 3x to the power 4 plus 4x to the square plus 2. And we're going to add now am plus the inverse of bm, minus bm. And we find 5x to the power 4 plus 3x plus 2 minus 3x to the power 4 plus 4x to the square plus 2. So the last three elements are in fact the parameters of the polynomial bm. Like we did before, we are grouping the terms. So first we have the terms in x to the power 4. We find 5x to the power 4 and minus 3x to the power 4. So we look at those and we can say this is equal to 2x to the power 4. And we write it as the first term of the equation. Now we look at the terms in the square. We have 4x to the square. There's only one term to the square. And we look at the term in x. There is only one term in x, which is 3x. And now we have the last two elements, 2 plus 2, which gives us 4. And that gives us the last element of this polynomial. And we find that am minus bm is equal to bx to the power 4 plus 4x to the square plus 3x plus 4. We can also do this in the other way, like we've seen before. So we can write the elements of the polynomials one below the other. So we find am on the top, and like we did before, the terms that are not present in the equation, we give them the coefficient 0. That's basically what it means. And now we subtract those. Now we don't take the negative, but we just take the subtraction. So we find that the difference of those two is first parameter in x to the power 4 is 5x to the power 4 minus 3x to the 4th, which is equal to 2x to the power 4. That's the first term of the difference. Then we look at x to the third. There is no term in x to the third, so we don't have to do anything with that. We look at x to the square, we find 0x to the square minus 4x to the square, which is equal to 4x to the square. We add this also to the equation. Now we look at the parameter in x, we find 3x minus 0x, which obviously is equal to 3x. So that's our term in x. And now we look at the last term, 2 minus 2 is equal to 4, and that gives us the last parameter of our equation. So that was the subtraction, the first example, and we did the subtraction in two different ways, like we did it before with the addition. Let's now have a look at an example where the two orders are different. And I find the first polynomial, a index m, is 5x to the power 6 plus 3x to the power 5 minus 4x to the square plus 2x minus 1. So this is a 6-degree polynomial, and a bn is the second polynomial, 4x to the power 4 plus 3x to the third minus x to the square minus 3x plus 4, and this is a polynomial of the fourth degree. We do the classical way. First of all, minus b index n, so we take the negative, the inverse of all the parameters. So we find minus b index n is equal to minus 4x to the power 4, minus 3x to the third, plus x to the square, plus 3x minus 4. Now we look at the addition of a index m plus the inverse of the inverse of bn, and we find the total polynomial 5x to the power 6 plus 3x to the power 5 minus 4x to the square plus 2x minus 1 minus 4x to the power 4 minus 3x to the power 3 plus x to the square plus 3x minus 4. And now we just rewrite the formula on the top, and we are going now to group the terms which have the same power in x. So first we find 5x to the power 6. The order of a is larger than the order of b, so there is no term from b that we add here. 3x to the power 5, there is no term of this power in b, so we just put it here, 3x to the power 5. And now we're going to see in a, we don't have terms to the third power and to the fourth power, so we look at the parts that we have farther in the expression. So we have minus 4x to the fourth and minus 3x to the third. So the first term, the next term is on 4x to the power 4, but minus. Then we have minus 3x to the power 3. And now we have again terms in x to the square, so we have minus 4x to the square plus x, which we can rewrite as minus 4 plus 1, x to the square is minus 3x to the square. We also have a term in x in both polynomials, so we find 2x plus 3x gives you 5x, and basically this is the term in x, 5x, and we only have to finish the last term, and we have minus 1 and minus 4, which gives us minus 5. Now, there is an important remark here, because when we were looking at the addition of two polynomials, we saw that the order of the sum of two polynomials is equal to the order of the polynomial with the highest order. In this case, m is larger than n, so when we do the subtraction, basically the new polynomial will have, in this case, the nth order. So we have the term, in this case, x to the power 6. And that's what I wanted to say about subtraction of polynomials. Basically, it's an addition with the inverse. And that's how we can easily do this, how we can look at the subtraction of polynomials. I stopped the video here because we did everything for this video. Anyway, don't forget to click on the subscribe button. Do not forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. I thank you and I'm looking forward to seeing you in our next video.